Welcome to Predicting Grant Applications, Building a Pipeline. After completing this lesson, we should be able to understand the role of pipelines in Spark ML, use a pipeline to fit a model and make predictions, and evaluate the results. Pipelines makes use of different components, which I've already presented in previous lessons. Regarding parameters, in an earlier lesson, we saw how one can use a parameter map function containing parameters to both transformers and estimators. Pipelines are a best practice solution to a frequent need in machine learning, where there is a need to combine multiple algorithms into a single workflow to produce the desired outputs. Pipelines are inspired by the scikit-learn project. They leverage the standardized APIs for machine learning algorithms in Spark ML. The refactoring done to support pipelines is the primary difference between the older MLlib library and Spark ML. As a pipeline is composed of different components, namely transformers and estimators, the standardized methods, transform and fit, turns the chaining of the different components of a pipeline into a straightforward operation. Regarding the properties of the components in a pipeline, notice that both transform and fit methods are stateless, and that each component is given a unique ID, as we saw before when assigning parameters to different instances of transformers and estimators. In Spark ML, a pipeline is a sequence of pipeline stages to be run in a specific order. It begins with an input data frame containing the original data set. As it passes through each stage, it is transformed into a different data frame. Each stage can be either a transformer itself or an estimator. The transformer stage is rather simple. It calls the transform method on the data frame. In the estimator stages, though, the fit method is called first, and a new transformer is produced and it becomes part of the pipeline model. Then it works like any other transformer stage. At the end, the pipeline outputs a transformed data frame which may contain several additional columns, depending on the stages it has been through. Notice that type checking is done during runtime, before actually running the pipeline. These 4 transformers and random forest classifier come from the previous lesson. Now we create an evaluator. Recall that the default metric for evaluating a binary classifier is the area under the ROC curve. This is a good way to measure the performance of a model. Now we want to split our dataset into a training set and a test set. We choose all grant applications before 2008 to be in the training set, and the test set is the grant applications from 2008. This holds out about a quarter of our data for testing. And here we have the results of our pipeline. It looks like fitting our model on the training set has resulted in over 90% accuracy when testing it on our test set. This looks promising. Now keep in mind that Spark is lazy. Nothing is computed until it's needed. This means that until you call fit on the pipeline, the transformers and estimator that make up its stages have not been executed. When you first put your pipeline together, you may discover problems in one or more of the stages that you created much earlier. So it's a good idea to first build a very simple pipeline with just a few feature transformers and a model, just to get things working, and then incrementally add stages once you have something working end to end. In the next lesson, we'll try to improve on this result by using grid search to find better parameters for the model. Having completed this lesson, we should now be able to understand the role of pipelines in Spark ML, use a pipeline to fit a model and make predictions, and evaluate the results.